Good morning. This is Jeff Feldman, Food Safety EDU. Mr. F, thank you for joining me again. I want to thank CS2 for the question that he asked me. He came through a school and a few years ago, and I got to know him back then. Really strong, very capable young man. A lot of props to him. So anyway, he's now out in the fleet. He's doing good things, and he came back for C school, and he came back because he's in the neighborhood, and he was asking me, he says, hey, Mr. F, what's going on with bromine in the water system for us on the boats and on the ships? And I said, what do you mean? He's like, well, you talk about chlorine for the water, but we use bromine. So how does that work? And I didn't know, so I had to look it up. So I'm searching still. This is kind of a down and dirty thing. I'm still looking and researching, but I found the World Health Organization did a report in 2018, so last year. This is 2019. This is July 2019. So last year, the World Health Organization put out this as bromine as a drinking water disinfectant. So the U.S. EPA has approved bromine as a disinfectant in the United States since 1976. Chlorine is the main disinfectant that we use in potable water systems for the last 100 years. And when I look at the other resource was the vessel sanitation program from the CDC, Centers for Disease Control and Prevention. They have a vessel sanitation program, and in their program, in the book or in the guidelines, Chapter 5, it talks about there we go, vessel sanitation, potable water system, chemical treatment. And the words that I'm reading are halogenation. So halogen. And that confused me. So I'm looking for bromine. I know about chlorine a little bit. I've heard about iodine. Well, it seems that the halogen ions these are all sister elements, okay? So we have fluorine, which is the strongest. Then we have chlorine, which is the next strongest. Then we have bromine. And then we have iodine. So these four are halogen ions. So in the VSP, in the vessel sanitation program, it's talking about halogen residual in the piping system, and you have to have the proper chemical injection feed unit. You have to have two of them in case one breaks down. You have to have the secondary, right? Everything has a secondary, I guess. Here in the VSP, Chapter 5, it says halogen residual. The halogenation injection equipment must provide continuous halogenation of the potable water distribution system and must maintain a free residual of halogen of greater than 0.2 milligrams a liter, or parts per million, and less than 5.0 milligrams a liter, parts per million. So milligrams a liter and parts per million are basically the same thing when we talk in measurement throughout the distribution system. So from a 0.2, which is very, very light, to a 5.0, which is pretty heavy, that's the acceptable range. So in the studies, the EPA, they come up with these maximum contaminant levels. So you can have maximum contaminant levels of certain things, metals, various things in the water I can't think offhand, but you can't go higher than this and still allow people to consume. So in chlorine, when we use chlorine on land, it's a 0.2 minimum residual all the way up to a 4.0 milligrams a liter, or parts per million, that range. And the thing about that is when people turn on their water tap at their house and they smell chlorine, they know it's there and they're not going to drink it. So it's that smell that stops them. There's independent operations that have their own water treatment. Say at a winery, they dig a well, then they put in their own water treatment, which would be filtration and then chlorination. And then they might use something else to take away the chlorination before it goes into the wine, because if there's chlorine that happens to get into the wine processing, it screws things up. So you have to have another filter to remove the chlorine before it goes forward. And then you have your ultraviolets, or what's the other one? Ozone, which has no residual. Ultraviolet will inactivate the RNA, DNA of the bad pathogens, so they won't reproduce, so they won't make anybody sick. Same thing with the ozone, but there's no residual. It only lasts for a short time. That's why in water treatment we can use those techniques for the initial inactivation of the pathogens, but then in public water systems, and we use chlorine, and we have a residual in the piping system all the way to your tap, to your house, so that it's safe all the way there. On the boats and on oil rigs and those kind of platforms, it seems that the vessel sanitation program requires bromine. So on land, it's a little more expensive, I guess, to use bromine, but on the sea, it is what it is. So bromine is the one. So you're testing the bromine all the time, just like you do chlorine, to make sure that your residuals are there and that your equipment is running properly. So looking at the VSP, and I would imagine it's going to be similar on Coast Guard vessels, it has to be controlled. So you have the residual is being pumped by the equipment. It's a chemical feed pump, and it's controlled, and it has to be analyzer controlled, so it's analyzed. At least one backup pump must be installed and ready to go in case the first one takes a dump. Chemical injection dosing point, potable water distribution, halogenation, and pH chemical injection dosing points must be located on the delivery line downstream of the potable water pump. So of course the raw water comes in, or the filtered water comes in, then it gets dosed, and then it follows out into the piping system, or distribution system is what we call it. Distant points. There has to be, at the farthest point, it needs to be at least a 0.2 milligrams a liter. So if you go all the way to the other end of the ship, when you turn on that faucet, it should still show as a 0.2. So no matter where you are, you get that. Data loggers. Electronic data loggers with certified data security features may be used in lieu of chart records. So you keep your chart records all the time you're recording, and then you can use data loggers, but the data loggers need to be, top of the line. So in food safety, for sous vide and for various food safety operations, we're talking about data loggers in distribution. In other words, coming on the truck, we're talking about data loggers in the storage rooms to make sure that the refrigerators are actually keeping the proper temperature, and the data logger logs the data. It's a memory, and it keeps it going. And so if there's ever a question, you take the information from the data logger, you plug it in the computer, or it's automatically attached to the computer, and you can look and review the data that has been logged throughout the system. And in this case, with the bromine in the ship, it'll record the parts per million. So that's going to be part of the SCADA system, system control and data acquisition. So SCADA is the digital ability to watch the computer, and then you have all the sensors and all the controls out in the field, and from your SCADA panel you can control increase chlorine, decrease chlorine, shut off pumps, activate pumps, things like that throughout this, and you have a continuous read and history. If there's ever any problems, you can go to that panel and you can get your information and make your choices, make your corrections. Okay, and then when they talk about equipment failure, so if that pump fails or if something fails, then you have to go manual, and then every 4 hours, someone is assigned to take that residual reading. So instead of working off of the SCADA system and just reviewing it on the computer, someone actually goes downstream into the piping, into the distribution system, and takes samples every 4 hours just to make sure that everything is still operating as intended while you fix the other thing, whatever it was, that the equipment failure, maybe the computer broke down or froze or something. I had that once. I went to one place, and it had been a week since I'd been there. My bosses, both of them, were on vacation, so I showed up, and the computer showed information. It looked like it was running, but when I transferred the information from the from the computer onto the paperwork, it wasn't right. The feed, I'd been going there for months and months, and every week I go, and the amount of water utilized, and the amount of chlorine used, and all the readings, the backwashes and everything else, they didn't jive. It didn't make sense. So I knew something was wrong with the computer. So I had to call one of the guys who no longer worked for the company, but he was able to walk me through rebooting the system. It wasn't just as simple as turning off the computer. You had to actually pull the SCADA panel and do a little thing in there in order to reset the system. And once I reset it, all the numbers came up on the computer screen, and they were all correct. But it was a worrisome thing for me, because if you don't know, and you don't have somebody to reach out to. So fortunately, before that happens, get your training and find out. Or thankfully, I had the resource of Richard that I could tap into, and he was willing to walk me through it, which was a bonus. And just like land, we have to take samples of the water. So we're looking for the residual to make sure that you still have a residual in the distribution system throughout, from the source all the way to the farthest end of the distribution system, any consumable. But then at those points, you still have to take monthly samples. It depends on where you are and what your regulations are. So we were doing monthly samples. So every month I had to go to all these different 30 public water systems, and I had to run the water. I had to disinfect the faucet. Then I had to wait. Then I had to run the water, catch a sample without breathing on it, coughing on it, without any trucks passing by with their exhaust getting into it, without me touching the inside of the lid or the threads of the lid. I had to, make sure my hands were either gloved properly, or I would use, not iodine, I would use rubbing alcohol to disinfect my fingers before I would touch the thing, all the time, making sure I didn't get those inside the water sample bottle. And then you send it to the laboratory. They do their analysis, and if there's E. coli, or coliform bacteria. So E. coli is a specific coliform bacteria. Coliform bacteria is more of a general one. So because of cost, normally they just do a general overview of the water sample. And if there is coliform bacteria in there, there are many, many different types, then we have to disinfect the system, chlorinate the system, or I'm sure on the boats you would brominate the system. Make sure it goes to a certain parts per million. So in the world, when we put new pipes in, it's 200 parts per million. Let it sit for an amount of time. Then you have to flush it out. Then you have to run water back through it. So if you're putting a new pipe in the ground because it broke, you have to isolate that new work area. Make sure that it's high chlorine for an amount of time to kill off whatever happened, and then you can run it and flush it and get it back down to the normal. So that's a huge amount, 200 parts per million. Whereas on your residual, you want 0.2 to 5.0. So that's really low. Now in the VSP, the vessel sanitation, it's talking about 50 parts per million, or 50 milligrams a liter. when you're doing when you're disinfecting certain things. So I'm going to have to look that up to see what other numbers I can find. The point is, and I don't know exactly because I haven't read the whole thing, but the point is there needs to be a residual throughout the system. You need to pay attention to it. You need to make sure not too much bromine is getting into the system and not too little. It's a continuous thing. The water is a consumable. People drink it. It goes into the ice machines. It goes through a filter into the ice machine, usually a carbon filter, creating ice in the ice machine. The ice machines can also, so I'm talking about water. Water goes into the ice machine, and if you're not sanitizing and cleaning the ice machine as intended or as maintenance requires, mold can build up inside the ice and inside the piping for the ice machine, and then aflatoxins may be created. And toxin is a poison, so it can poison people when they drink their ice soda or their water with ice in it. Or if you use ice and you use it to cool down a stock pot, ice is a potable thing. It's okay to use it in cooking. We just don't store food on ice. So if I have a whole bunch of ice and you put my Coke cans in there to keep them cold, once we use it as storage for that type of environment, right, putting things into the ice just to keep it cold, then it's no longer a potable item. Now you can't, or consumable, because it was a storage thing. You have to discard that ice. But you can certainly use ice directly from the ice machine and get it into the food to cool things down, or whatever technique you're using. That's okay. But for storing food on ice, or storing items on ice after it's stored on the ice or in the ice to keep it cold, then that ice is no longer consumable. I hope that makes sense. But the ice machines and the aflatoxins, toxins, once they're built up or once they're there, you can't kill off a toxin. The toxin is there. You can't cook it away. You can't wash it away. You can't freeze it away. Nothing you can do once the pathogen is turned toxic. So wash your ice machines. Check your ice machines. The tubing, the piping in the back, you have to actually unscrew things. Look inside. Use a bottle brush to get inside those tubes. Make sure your doggone filters, the pre-filters that go to the ice machine, are changed out like they're supposed to be. Usually once a year, but sometimes it depends on the usage. It depends on how much water is going through that ice machine as to how strong your carbon filter is going to be over time. Each one has its own life. Every filter has its own life, and if it gets clogged or diluted, you have to change out those filters. For undersink reverse osmosis in a home, if you go to Costco and you buy a reverse osmosis unit, or you call one of these companies like the company I work for, we would come with 3 filters: a pre-filter, a membrane, and a post-filter for reverse osmosis under the sink. The membrane in the middle, we would say that's good for 5 years, but the pre-filter and the post-filter, we would tell them it's 1 year. Now, when you read the literature, it says maybe 2 years for those. The point is they only go so long. If you go to your refrigerator and you happen to have a water and ice maker on your home refrigerator, there's a carbon filter that's somewhere in line. On the back of it, in the ceiling of it, wherever it's going to be. But then your electronic sensor on your refrigerator is going to say, hey, every 6 months you need to change your carbon water filter because it's time. Now, it may be actually, it's based on the amount of water that you push through that unit. So the point is, as I'm just droning on and on, is that filters need to be changed. They need to be maintained all the time. They get dirty, they get nasty. I had kind of like a swimming pool filter. You have to undo the lid. You have to shut off the water, undo the lid, take out the filter, and it's full of dirt and leaves and bugs and worms and whatever else, and you have to spray it out. Drinking water is the same thing. We have drinking water system, filter system, that have calcite filters. Those change the pH. They're neutralizers is what they call. So sometimes in certain neighborhoods here, we have water that comes from a well. Okay, many municipalities have wells where they dig a hole down in the ground and they suck, like straws, they suck the water out of the wells. Then there's surface sources, which are lakes and rivers and streams, and it all comes and gets collected. Okay, there's collection, and then it goes to the water treatment plant. So if you have your own well on your own property and you have your own vineyard or apple orchard or just your house out in the country and you have a well and maybe you dug it yourself, so it's a pump and a motor and pipes that are shoved way down 70 feet, 100 feet, 1,000 feet, whatever it is. Then it comes to the top, and then there's pipes from the top of the wellhead to your house. When it reaches your house, normally on the outside of the house or maybe in the garage, it goes through the filters. So it goes through maybe a calcite filter to neutralize it, because maybe that water from the well is really acidic. And if the water is really acidic, below 6.5, 6, 5 point something, which they are, some of them, it'll eat the copper of the pipes in your house. If you have copper piping, like normal residential copper piping that you drink from. If the water is acidic coming from your well, it'll start corroding and eating away at the pipes inside your house. So then you're drinking copper. And then the solder from the old days was lead. And so then you're drinking copper and lead. And just like Flint, Michigan, people get sick. It's brain damage for the young, it's illness, it's sickness. So that's why we have filter systems before you actually consume it. This is on land, and I'm sure it's on water too. There's other filter systems I don't know about. But the point is that any source of water comes in, you never know what it is. Now, we assume the water in the wells down the hole is safe. That's been the thinking forever. But now, because of gas stations and laundromats and rocket fuel dumps, all those residual things seep into the ground, and then they get washed into the groundwater, which are streams and lakes and big reservoirs. So when all this crud leaches down into the ground over 50 years, from the 1950s and 60s and 70s, it contaminates the groundwater. So now when you pull groundwater at your house over in the other town, you're still tapping into the larger overall underground source, which is the underground water. Forever, for years, they said groundwater is safe. You don't have to worry about any of it. Okay. It's more safe from contamination than surface water. Surface water, you have raccoons and deer and jaguars and, cougars, and they poop in the woods. And then it rains, and that poop gets washed into the creek, and then the creek goes down to the river, and the river goes into the lake. So there's always feces. There's always organic contaminants. There's seaweed in there. There's leaves. There's grass. There's all kind of stuff. Whatever washes into the lake. So in the old 1800s, we would go and we just drink, make sure you get a babbling brook and you drink it because it's babbling, it's moving. Well, but the raccoon and the beaver, they pooped in it. So even though it's moving, the poop is moving down that stream too. You don't know what you're getting. So there's Giardia, which is the beaver fever, right? Causes illness, right? Vomiting, diarrhea, terrible fever. There's Cryptosporidias, another parasite that protozoan parasite that's in the water. It's so resistant to chlorine and to bromine. You have to have a higher concentration in order to kill off the crypto. And then there's cyclospora, which is another one that gets into fruits and vegetables. So let's go back to the cryptosporidias. 1993 in, where was it? It was back east somewhere, one of the big cities. They had 2 water treatment plants, and one of them became contaminated with cryptosporidias. And what it does is, if you look at, what's the TV show? Monsters Inside Me, and find the one on crypto. So it's a little nodule. You drink the water, you eat the food, the protozoan parasite is there. And it gets into you, and it gets into your intestines, and you know it's there, and so you have terrible cramping, and then you're trying to get rid of it. How do you get rid of it? You're trying to diarrhea, right? You diarrhea to wash it away, but it's holding on. It's like it's clamped onto your intestines, so you try to go diarrhea. Pretty soon, you become dehydrated because you're going so much to get that away, but it's not going anywhere. And so, what was it? 4,000 people were hospitalized. Over 100,000, 111,000 people were sick. 30 people died, or 11 people? I think 30 people died. So who would die? If you're diarrheaing all the time, and this is potable, you go to your kitchen sink, you drink it, and you get sick. In this city, this is a resistant protozoan. So that's why we have filters also to get rid of those. That's why there's reverse osmosis. That's why there's ozone and ultraviolet, right? It stops them from reproducing. So it's a big thing. But those things can be in the water, and you got to filter it. Then you got to get a residual disinfection into your distribution system. Oh goodness, I got on a roll here, and I got, let's go back to bromine. So with the bromine, the World Health Organization, they have this report, and it's an alternative to chlorine, right? Where is my thing? So back to my report. Bromine is a drinking water disinfectant. Chemistry Basics, Chapter 2. This is from the World Health Organization, that 2018 report. Bromine, chlorine, iodine, and fluorine belong to the halogen group of elements. All of the halogens share a common property of being oxidants with 7 electrons in their outer shell. Fluorine is the strongest at 3.98. Chlorine would be next at 3.16. Bromine is 2.96, and iodine is 2.66. This is the Pauling nomenclature of electronegativity values. Water solubility and taste and odors. Bromine is more soluble in water than iodine, but less so than chlorine. Okay, free halogen. Bromine can be further oxidized to form. No, don't worry about that. All right. FSE. So bromine is primarily used as an alternative disinfectant for swimming pools, spas, and cooling towers, but not for municipal drinking water, partly due to cost and partly to concerns about the formation of brominated DBPs, which are disinfection byproducts. However, the disinfection for drinking water with bromine has been recognized and allowed by the U.S. EPA, the Environmental Protection Agency, since 1976, although not for use as a municipal drinking water disinfectant. The use of bromine to inactivate bacteria, viruses, and protozoan has been reported in a number of laboratory scale and disinfection studies, and they list a whole bunch of these studies. The effectiveness of bromine against cysts of the protozoan parasite Entamoeba histolytica, which is an intestinal parasite that is one of the California Big 5 or Big 6, has been shown to be greater than chlorine or iodine. So that was a 1975 study, so it's stronger against Entamoeba histolytica than either chloridine or iodine. In addition, evidence of bromine inactivation of purified Cryptosporidium parvum, which is the Cryptosporidius that I was just talking about, the one that made all those people sick back east, osis, infectivity in cell cultures has been reported. However, cystoidal studies assessing the inactivation of the waterborne protozoan parasite Giardia by bromine has not been identified, so they didn't do that one. So both bromine and chlorine, when they're used in the water treatment, they can lose, depending on contamination that gets in the water. So the chlorine, they call it breakpoint chlorination, and I'm sure it's similar with bromination. Depending on what's in the water, you have to add enough chlorine to overcome whatever the contaminants are in the water. The disinfection byproducts that they mentioned a minute ago for the bromine is the same thing with the chlorine. We have disinfection byproducts, and it's usually associated with organic material like the grass and the leaves that gets into the water. So then when you try to do breakpoint chlorination to overcome what's ever in the water, if there's organic material in there, the chlorine and the bromine will react with those materials, and then they change. So for chlorine, it becomes trihalomethane. So it changes the molecular structure of these units, and they become carcinogenic. They become cancerous. And so depending on the water system, they're there. It's a well-known fact for water treatment people, these byproducts are there. So one person drinking water out of 100,000, or so many anyway, I'm not going to say a number, but they're going to get some kind of cancer because of what's being used to treat the water to keep it safe. It's kind of an offset. Before there was chlorination, before there was bromination, before there was treatment, it was just dirty water. People drank it and would die from, hundreds of thousands per year because of things in the water. And then they would be, they'd become dehydrated and die. Typhoid fever, cholera, all these things. So now we have this disinfection system to defend against those pathogens. Same thing in food. We're defending against the pathogens. But on the backside, there is an issue that the byproducts are there. So every city, every town, every municipality has to put out, what's it called? CC&R, Consumer Confidence Report. Every year, what's in the water. It's kind of like when you look at a cereal box and it has a list of ingredients on the cereal box. What's there? What could be there? What are the allergens, right? The 2007 labeling law says now you have to write the allergens in clear words rather than saying it's something with a technical term. Now you have to say it's either milk or wheat or, whatever the clear term is, or peanuts. So for water treatment companies, they have to report a CC&R, and it has to go to the customer. So when I was working for the one company, I would go to those 30 places every week, and then at the end of every year, the report would be compiled based on our testing and our treatment, and it would go to the customer so they can see what happened over the course of the year and what is in the water and what we're trying to take out with the filter system so that they're aware of it. Same thing with cities. So I'm here in my town, and a few months ago I got a CCR from the water treatment company here in the town, and it tells me what's in the water. And so a lot of people based on that will actually run out to Costco and get their reverse osmosis unit and stick it under the sink. So anything they're going to consume is going to go through that filter system. Or they're going to contact a company like my old company and bring it in and set it up in the garage so the water goes through these water treatment filters before it comes to the water faucet. So a lot of things, the pH, the alkalinity, what's in the water, parasites, contamination, pathogens, viruses. So we want to prevent all these things. We want to keep people healthy and safe, and that's what the intent is. And so it's a strong thing. It's a strong thing. So as cooks, we need to know where our food is coming from. We need to know that it's coming from an approved, reputable supplier. And the same thing with the water, because water is a consumable too. When it comes through that piping system, goes to the ice machine, goes to the soda machine, goes to the ice machine in the soda machine up on top. Who cleans that? How often is it inspected? Now, I know the HSs, I know the health service people. They go through and they take samples and they see what's in the water. I don't know what they're looking for exactly, but I would pull apart the things, get up on a ladder, open it up, and look for green mold in your ice, because the test may be looking for bacteria, but it's not going to look for mytoxins. So I'd look for that. Anyway, I'm going to get off my soapbox now. Thanks very much for listening. And this one was kind of down and dirty, and I went off on a side tangent, but I think the information is there. Bromine is a halogen, like chlorine, like fluorine, like iodine. It's what you guys will use on your boats. You have to make sure that there's a residual of 0.2 or greater up to a 5.0, not larger than a 5.0. Now, qualifier, or this is from the VSP and the World Health Organization, the information I got. I'm looking to find more information in the Coast Guard information and their resource, and I haven't found that yet. But I've been wanting to get this podcast up and out so at least people have an idea of what's going on with their water, both on the boat and on the land, and I hope it helps. So thanks very much. Take care and enjoy the weekend.